Hi guys, today we're going to go over 1-5 conditional statements. But before you do that, I want you to go back to Google Classroom. There's a link for Solve Us Realize that says Review Lesson 1-4. I want you to pause this video, go back, and do that review. That's from what we did last week. It's 4 questions, and I just want to see where we are on it. Then come back to this video and take notes. Okay, so this is notes just like if I was in class with you notes. I expect to see them completed tomorrow. And let's get started with lesson 1-5. So what a conditional statement is, and the short version, is a statement in if-then form. So we're going to be writing some sentences today that have to do with reasoning, right? We talked about inductive reasoning last week, and we're going to continue to talk about that this week. The if part is called the hypothesis, kind of like in science class, and the then part is called the conclusion. And sometimes we'll see it in symbols too. If you see it in symbols, it looks like this: P, arrow, Q. And we read that if P, then Q. So the first thing we need to do is make sure we know how to take a sentence and write it as a conditional. Okay, so here's our first example. And we're just going to use a generic not math sentence. You can register to vote if you are 18 years old. Okay, so this sentence is not a conditional, but it's a sentence that has a condition, right? You can vote if you're 18 years old. So if I asked you to write this as a conditional statement, the if part is the hypothesis and needs to go first. So we see here in this sentence, the if part is you are 18 years old. So to write it correctly, I would say if you are 18 years old, then you can register to vote. So in a nutshell, that's what a conditional statement is. Now, of course, we're in math class. So let's look at one that's a little more mathy related. Okay, so this is still part of example 1. This is just a math version of it. Let's see, a square must have 4 congruent sides. Okay, so this one's a little trickier because the word if is nowhere in this statement. However, it still has a condition in it. A square is a square only if it has 4 congruent sides. So we need to think about how we can say that correctly using the right kind of language. So let's start with the hypothesis. So we want to stay away from things like if it is, be specific with the it. In this case, the square is polygon. So I want to state specifically if a polygon is a square. It's totally okay to add words to help you define something like that. So if a polygon is a square, then it has 4 congruent sides. Okay, so that is writing a conditional statement. So I'm going to give you one to try, and whenever I come back tomorrow, I'm going to ask you to show me the correct answer. So this is the one that I want you to try. Again, you're writing this as a conditional statement. A triangle with all angles congruent is equilateral. So let's see what you come up with. All right, so if you, here we talk about the truth value or see the word truth value. Moving on. Well, in geometry, there is no gray area, or in math. A truth value of a statement, it's either one or the other. It's true or it's false. Now, some of the truth statements you're going to be asked to find the truth value of, you do have to have a little bit of a background of math knowledge, like even and odd, composite and prime, things like that. So like an example would be, this is example 2. If a number is even, excuse me, then it is divisible by 2. So if I asked you the truth value of that statement, you would tell me true or false. In this case, it happens to be true, right? All even numbers are divisible by by 2. Let me move right on along. So I want you to try this one. I guess this one is assuming some previous math knowledge. So let's see how we do. If a quadrilateral has a right angle, then it is a rectangle. Okay, so again, what you're doing is you're telling me the truth value of that statement. And if it happens to be false, I want you to find a counter example. We talked about that last week. Okay, so here comes the fun part. So we take these conditionals and we do things to them. Like we can write them backwards. We can add the word not, and we can do both sometimes. So I'm going to go over some vocabulary words that you need to be familiar with, and I'm going to write them in symbols, and then we're going to do a couple more examples. So let's start with a Converse. Not the shoe, as awesome as they are. I love my Chucks. So the converse of a conditional statement is just when you reverse the hypothesis and the conclusion. So just a reminder, as I said a minute ago, we can, let me use green, okay. If we think of a conditional statement of if P then Q, right? Again, if was the hypothesis and Q is the conclusion. The converse of that would be Q then P. Like you literally just switch the words behind the if and then. Now the if and then are going to stay in their place. It's just the verbiage. So if I were to go back up, for example, like to the you try that we just wrote down. If I were to find the converse of that, it would be if a quadrilateral is a rectangle, then it has a right angle. So we're going to practice that here in just a second. All right, so the next one would be a negation. A negation is whenever you say something is the opposite, has the opposite meaning. And here, we just usually either add the word not or we take out the word not if it's already in there. You can do this to a conditional statement, which we're actually going to do in a second, but you can just do it to only the hypothesis or only a conclusion. So the symbols for that, for a not, is that little wavy line. It's called a tilde, actually. And then your statement. So like if I said today is Monday, the negation of that would be today is not Monday. You're just adding the word not or taking the word not away. An inverse is where you use the negation on both the hypothesis and the conclusion. So in symbols, that would be not P, then not Q. Q. I said Q and I wrote P. Let's try that again. There we go. So the inverse is where you add the word not or do the opposite of both the hypothesis and the conclusion of a conditional statement. And then the last one is a contrapositive. Contrapositive. So a contrapositive is where you take a conditional statement and you do both the converse and the inverse to them at the same time. So not only are you switching the if and then statements, but you're also adding or taking away the word not. So that would be not Q, then not P. Okay, so those are the 4 things that we're about to do to a conditional statement, okay? So I'm going to show you an example of each one of those. I believe this is example 3. If I'm wrong, I'm sorry. I do know how to count. I'm a math teacher. Let's see. What's a good one? I'm trying to find a good example here that I like. All right, so let's do one that's not math related. All right, if you play the trumpet. By the way, I played the clarinet in high school, just a tidbit of information. If you play the trumpet, then you play a brass instrument. Okay, so that is my original conditional statement. So first, let's do the converse. Okay, so this is the converse. Now remember, the converse is we're just going to switch the if and then portions, but the if and the then are going to stay. So that would be if you play a brass instrument. If you play. I can speak and write at the same time. Wow, I can spell too. Then you play a trumpet. Play the trumpet. So you can see all I did was switch the if part and the then part, but the if and then stayed. So it's still a conditional, it's just switched. Now, the thing is obviously the original conditional was true, right? If you played the trumpet, then you played in the brass section. But the converse is not necessarily true, right? For those of you who play band or are familiar with band, there are more instruments in the brass section than just the trumpet. And I'm sure you could give me several counter examples. So the truth value of this particular converse happens to be false. They're not always false, but this particular one happens to be. Ooh, my pen's going crazy here. I'm trying to change colors. All right. So let's look at the inverse. Okay, so the inverse, again, going back to the original, would be if you do not play the trumpet, then you do not play a brass instrument. So notice the if and then part stayed where they were. I just added the word you do not, you do not, right? I negated those two statements. Remember, that was a negation. Okay, so this particular one also happens to be false. Again, not all the time are they false, but this one happens to be because if you do not play the trumpet, meaning you could play any other instrument, then you do not play in the brass section. Well, yeah, that's not true. You could possibly play a trombone, for example, but you definitely still play a brass instrument. All right, finally, let's look at the contrapositive of this statement. Okay, remember the contrapositive is where you do both. Again, going back to my original statement, I'm going to switch them and I'm going to negate them. If you do not play a brass instrument, then you do not, well, don't, same thing, play the trumpet. Wow, where am I going with that? I do know how to spell trumpet. Okay, so that is the contrapositive. Not only did the if and then switch, I also added the don't part. Okay, so what I want you to do is I want you to tell me whether or not you think that is a true statement. So tell me the truth value of that contrapositive. All right, so to end it out, here's what I want you to do. One last you try. I'm going to give you a statement, not Trey. Good gosh, guys. And I want you to give me the the converse, the inverse, and the contrapositive, and see if you can tell me the truth value of each of those statements. So I'm going to give you a math one, and we're going to see how well this goes. So the statement is, if a polygon, remember polygon is just a fancy geometry word for shape, is a quadrilateral, it's a four-sided figure, then it has four sides. Okay, so one more time, that's the original conditional. I want you to write the converse, the inverse, the contrapositive, and tell me the truth value of each one. If the truth value happens to be false, I want you to give a counter example. And I will be checking these whenever I get back tomorrow. And I missed you guys today. Please remember, you can always send me a remind message on your computer if you have a question during class time. And as long as I'm available, I will absolutely answer it as fast as I can. You guys have a great